In this video, we are going to talk about significant figures. So significant figures provide us with the range of values to expect for a repeated measurement. So the greater the number of significant figures, the greater the certainty of the measurement. There are some rules to count the significant digits in a measurement. So rule number 1 is that all non-zero digits are significant. Rule number 2 is interior zeros are significant. Rule number 3, leading zeros are not significant. Rule number 4, trailing zeros after a decimal point are significant. Rule number 5, it's trailing zeros at the end of the number without decimal points are not significant. So we can see how these rules apply to our measurement by doing the example. So in this example, it says how many significant figures are in each of the following measurements. So example number 1, it's 0.0546. So we can see that 0.0 are the leading zeros, and it says the leading zeros are not significant. So we know these two are not significant. We're not going to count them. And then we see 5, 4, 6, which are non-zeros. So all non-zero digits are significant. So we're going to say 1, 2, 3. So in this measurement, there are 3 sigfigs, which is short for significant digits or significant figures. So in question 2, it's 5.003 kilometers. So where we have 5 is a non-zero, that's significant, and we have 2 internal zeros. So interior zeros are significant. So we have 2 interior zeros and then 3 non-zeros. So we have 1, 2, 3, 4. So 4 sigfigs. Now for example 3, the measurement is 1.000 times 10 to the power of 3 seconds. So we can see it's written in scientific notation. So since the zeros are trailing after the decimal points, so trailing zeros after the decimal points are significant, so we're going to consider them significant. And 1 is non-zero, it's also significant. So 1, 2, 3, 4. So we have 4 significant figures in this example. Now for the last example, it is 10,000 meters. Now 1 is a non-zero, it's going to be significant. Now we have 1, 2, 3, 4 zeros trailing, but there's no decimal point. We don't see any decimal point, and the trailing zero at the end of the number without decimal points are not significant. So all these zeros are not significant. So in this measurement, we only have 1